Could I make a remark about randomness in quantum physics? I think it's a source of creativity, actually. If the world had been completely deterministic, in some ways it would be a bore. But since at a quantum level, all the time, God is tossing a coin, that generates surprise and generates novelty. And Darwin thought this was where biological evolution came from. He replaced God by randomness. And the theme of randomness was one of the points of dispute between Einstein and Bohr, of course, and really is viewed as a fundamental part of the package of quantum mechanics, of our fundamental physics. So indeterminacy seems to be very, very basic, and little things like space and time, who knows how they're going to end up.
But you know, sometimes...
And reality also, reality, entre guillemets, in quotes.
You know, but sometimes we think we need new concepts, but maybe it's also because we forgot old concepts that could work. I'm thinking about Immanuel Kant, and it's not an obsession, because those last few years I've reread Immanuel Kant. And when you are talking about space and time, Immanuel Kant said that actually space and time, he called them the form of our sensibility.
Right.
And so when he said that, you know, and he said there is the category of our understanding, that is causality, and the form of our sensibility are actually space and time, but there are nothing else for him. Nothing else. That means, in fact, for him, when we are talking about the real, what he called the noumenon, not the phenomenon, not what appear to us and that can be object of science, but the rest can't be object of science. The noumenon can't be object of science, and at the same time, it's the only thing that is real for him. Space and time, for him, don't mean anything related to the noumenon. Anything at all, you know? And he doesn't even need quantum physics to say that. He just needs to be coherent in a way. And it's what he does in a part of the critiques of pure reason. It's called the antinomies of pure reason. And it's very interesting because he just says, because we are talking about God, he said, in a way, I mean, of course it's my interpretation because I can't help doing that, but you know, Saint Anselm of Canterbury or Thomas Aquinas and all those people, they try to demonstrate the existence of God with some kind of very logical demonstration, etc., etc. Kant said, you can't demonstrate God in a regular way because you will have to use causality to demonstrate God, and God doesn't have anything to see with causality. But you can use causality to show the necessity of existence of God. And it's when it becomes tricky and very intriguing, and I think it could be useful even nowadays. Because he said, if you use causality, cause and effect, and it's what science is about basically, considering things like always being the effect of a cause that you try to find, and you find the law of this causal process, etc. If you use it metaphysically, so you will enter into what he called antinomies. For instance, if you say, when will be the beginning, as I said, you know, yesterday or the day before yesterday in the conference, I think you were there, I don't remember if you were there or not.
I was there.
Yeah, and I say, you say, it's the beginning. Is it the beginning of the universe of everything? The beginning of everything, whatever that means. He didn't even think about, of course, about the Big Bang and all that. And so if it is the beginning of everything, you say, it can't really be the beginning if you are thinking in a causal way, because you always need to think that the cause is in the same time the effect of another cause. Otherwise, you're not thinking causally. So if you do that, it has to have something antecedent, something before, so that doesn't work. So if you say, okay, it doesn't matter, I'm not going to I would say the universe doesn't have beginning, but if you say the universe doesn't have beginning, that means there is an infinite, a time that has never started, and you are not even able to think, if you think this way, that when you say, let's say, any event, like an event like the day I was born, so just when you pronounce this sentence, there was an infinite time before the day I was born, so that means you can never be born because it's an infinite number of times. So that doesn't even mean anything. That doesn't have. I don't try to justify it. But he said, you see, if you try to justify the existence, the very existence of causality within itself, but you push it at the very end, causality itself can't exist. Therefore, because causality exists as the appearance of things that have a certain regularity that can be the object of science, there is the necessity for another principle or something else to exist that I call the noumenon. That is not, And I think it's very interesting to think this way, because for him, actually, causality as the category of understanding and space and time are just form of sensibility, are not the real. They almost don't have anything to be related. Of course, there is a relation, but we're unable even to grasp this. Of course, what we have done with time, we could do it exactly the same way with space. Because if there is a limit, what is behind the limit, etc., and so, And so, I think we could reread even Immanuel Kant. I'm not very original when I'm saying that, because I'm thinking that there was a book about Heisenberg and Immanuel Kant, even a book by Heisenberg that is saying that he thinks that he found a lot of inspiration in Immanuel Kant's idea.
Yeah, well, I'm not capable of reading Immanuel Kant, not in the original German and not even in English, but I read a lot of Einstein's essays, and he read Immanuel Kant, and Einstein's point of view, which I imagine follows Kant, is that we invent the notions of space and time, even numbers 1, 2, 3, 4, 5, because they help us to organize our experience. I guess Kant said we don't have direct contact with reality, right?
Of course, exactly what he said.
Right.
It doesn't even mean anything to say that we are.
Now, causality has suffered a strange fate for some time, actually, because you can get rid of it in current physics. You can have minimum principles. So instead of saying that they're infinitesimal chain of cause and effect that makes something happen, what you can say is that the whole trajectory minimizes, for example, the, something, which would be the difference between the kinetic and the potential energy, I think it's called. Anyway, you can formulate things as global minimal principles. And it turns out that's equivalent to saying that there are instantaneous propagations. Because, so physics can be formulated either way, actually. Another comment I would make is, I wouldn't argue with Kant, I'm incapable of doing so, but physics, in a way, there's a position that physics only makes models. I like a more romantic view. I think that physicists are trying to do ontology. I know that among philosophers, ontology is not very popular lately, since the pre-Socratics. Then it was very popular. But I feel that what fundamental physics attempts to do, in its own way, is to go in the direction of trying to determine the fundamental ontology of the world, poking nature with experiments, partly by pure thought, but always one has to poke to see if nature agrees, right? And that perhaps Kant denied the possibility of doing that. At his time, it was not possible. But the experimental techniques available now are quite astonishing. And I think it's more of a question of fashion, whether you say that physics just makes models, or you say that physics really attempts to push and see the basic ontology of the world.